be done by an system developer to make a mobile platform resilient and secure. So along with that, we will touch upon how a developer, or for that matter, even how a user can make use of the security features of a mobile platform. And maybe for an enterprise, how you need to, what are the considerations you have got when you select a select any computer platform for that matter. So this is what we will be seeing. We will be looking at mobile security, a overview, and we will be looking at Android specifically because that's what I am working with. And in our context, I think that's the majority of the mobiles in India, smartphones in India are using. We'll be looking at briefly at the security model. We'll be looking into what are the platform hardening measures which can be done. So let's see what's mobile security. Security, as all of us know, it's an aspect of a system. Just like how correctness is an aspect of the system, security is another aspect of the system. So, and then why it is important. So I think that need not be explained. All of us know why it's extremely important. We have got a lot of sensitive and very important data, our financial data, our personal information, all these are currently in our mobiles. And then how we can make it secure. So that's something which you'll be seeing. So we'll be looking at ecosystem, application security. So why ecosystem is important is Android is a complex ecosystem. It's not just one device manufacturer or just one platform vendor. It's a pretty complex ecosystem, so that complexities of the ecosystem has an impact on the overall security which an end user get when he is using a mobile. So that's important for us. And we'll be looking at, when we look into security, there are two aspects of it. There is an enterprise who is looking at security from an enterprise perspective. That's different from a consumer who is looking from his perspective. So we will touch upon both. And this is in the Indian context. I think we need not explain this. We already know with the digitization, with our government's push on moving a lot more transactions to mobile, and our insistence on various payment mechanisms which are powered by mobile, our identity, our Aadhaar scheme, which has got, people has got options to identify themselves using their biometric identity, using their mobile phones. So the security of these devices, these end user devices, is extremely important for us, especially for our country and at this point. So these are the various reasons. I think this is pretty much, okay, then one more aspect for it. When we buy a mobile or when we use a mobile, so one aspect which we normally won't consider, which is being overlooked quite often, is how reliable that platform is. So what are the measures which has been taken by all actors in this ecosystem? The application developer, the platform vendor, and even the OS provider. In this case, in case of Android, it's Google. What are the measures they are taken to ensure that your data is secure, your transaction is secure? So that's an important point. So that is why it is, and when you have got a plethora of options in the market, you have got a lot of OEMs, you have got a lot of devices, and in India, we do have innumerable number of devices and OEMs. So how do we make sure that these things are happening? The choices we are making is most secure. The threats, I think, as we know already, we have got various kinds of threats. There are surveillance threats, billing, and there are issues with data theft. And of late, there is a banking frauds which are happening. And there is possibility that your mobile can be part of a botnet, which is used for launching a DOS attacks on some other, let's say, on some other systems. The attack surface, I think many of us here will be having a good idea about security and the attack surface. We know that Android provides one of the, or for that matter, any smartphone provides extremely rich attack surface. There are web vulnerabilities which can be made use of. The third-party applications, the level of trust what is there in a third-party application is always a question. And the capabilities which is there in a third-party applications, what can use. It can have dangerous level of permissions. And there are a lot of media and document level of vulnerabilities are possible. Then, of course, there are all hardware threats associated with it. So it provides a very interesting, in terms of, from a security perspective, it's a pretty complex attack surface, and it gives us a very interesting target for any would-be attacker. So ecosystem, this is what we talked about. There is Google, and there is the system-on-chip manufacturer. So we'll be knowing about the Qualcomm or MediaTek, or let's say Exynos. There are different different vendors of this system-on-chip. They do have an impact on the security because they are the one who are providing the various drivers. And let's say they will be providing boot-level components. They will be providing the drivers. So they will be making modifications in the kernel. So there, the measures what they take for ensuring security has an impact on the overall security of the device. And the OEMs. OEMs, okay, if some of us are, at least if you are familiar, we know that there are different permission levels in every phone, in every computer system. Certain applications has got, or certain processors has got more permissions than the other process or other application. In case of Android, we have this third-party applications which we can download from the app stores. They have certain level of permissions, and there are applications which are embedded in the device or pre-built in the device by the OEMs. They do have a higher level of permissions, what we call as system level permissions. So how secure those applications are? So that's also a question. And of course, the developers. What are the security measures taken by the developer? Have they taken, did they make sure that the data at rest is protected? And are they using the right cipher suits? And are they using, have they done a due diligence in terms of a pen testing or any certification before they release this application to the market? All these will have an impact on the security what consumer get finally. So this again the security model. So okay, this is a little bit of system level details. I think we can just assume that there is a application level applications has got certain levels of permissions and privileges, and then there is a system which has got certain levels of privilege. That's OEM applications, and then there is kernel, and there are systems with root level of privileges. This is a little bit detailed view of security model. We'll touch upon each of these points in the further slides. So anybody who tried to develop or deploy an application, we know that an application needs signing. So one thing which we need to note in this slide is an application, there is a developer who is signing an application before I am deploying it. When I deploy that application, that signature doesn't mean a signature in the regular PKI model. So when I sign, let's say I'm signing an email, I am signing a document, it means that that signature is a proof of my identity. So if somebody is going to sign somebody is going to trust me based on my signature, because the the certificate vendor has taken some measures to ensure that I'm the right person who is in possession of that certificate. But at least in case of Android, the application developer can use a self-signed certificate. So an application is signed doesn't mean that application is trusted, or doesn't mean that developer is trusted, or doesn't mean that the application is devoid of any vulnerabilities or any issues. The permissions, we talked about the different levels of permissions. So I think, yeah, it depends upon the level, it depends upon who developed it, who is deploying it. Different applications has got different levels of permission. And another model is the secure networking features what are provided by any platform. So we have this, at least in case of Android, it has taken some special measures to make sure that not every application can connect to the internet unless otherwise the user has specifically given permission for that. And then there are, for enterprises, there is a rich VPN support is provided. So one important point what we need to note in this thing is the security what is available for an end user depends upon what measures again the developer has taken. If the VPN suite supports the latest cipher suite, that's fine. But otherwise, if they are going with some cipher suites with non-vulnerabilities, then there is an issue with it. Or the permissions for the user, if the user is randomly, without looking at the trust level of the application, randomly trusting every other application to access internet, then there is going to be an issue that particular application may be taking all the personal data and it will be sending it across to some remote server for some other purpose. So the device management, this is mainly for the enterprises, smartphones in general. Android in particular provides a plethora of options for device management. And there are OEMs who are extending it and giving very granular level of device management. But this is basically for the enterprises. So enterprises can make use of this functionality of this device management to make sure that the devices are secured. And in case of a device loss, they can actually remotely erase the device or lock the device or take some remedial actions. In terms of cryptography, there are rich cipher suite is available as part of the Android, and it keeps improving release after release. But again, the question is what options the user is going to take, what options the developer is taking, and how that cryptography is implemented. So that calls for some level of reviews, some level of discipline in the development process. So otherwise, even with this rich cryptography suite which is available, the application finally may not be secure. The multi-user thing, this is important from a security perspective, because one thing is the inherent Linux distribution of between two different users is provided by this. Plus, many of us might have heard about different Android for work and other container concept, one for the personal and one for the enterprise. And so all these container concepts are powered by the Android multi-user. So it provides some discretionary access level control differentiation between the enterprise usage and the personal usage. And it provides some Linux policies as well. The authentication, so again, the smartphone platforms provided hardware-backed authentication. So both for the fingerprint as well as for the PIN, keypad, or touch. The sandboxing, which all of us are, at least some of us who might have looked into Android or might be knowing about this already. Every application every application has got an UID, and it works as an individual. It works in its own container. So this provides some level of data separation between different applications. Unless otherwise, two applications are signed with the same certificate, they will not be able to share data. So that is the reason how our each application's data is secured. Android provides a binder IPC. So that's again, a binder has got some special features to make sure that only the right application, the application which has got the right permission, can talk with the network or talk with other application. The concept of applications talking with each other and filtering that is done by the binder. So FDE will be pretty familiar, or many of you might have heard about FDE, because there is this famous case of Apple versus FBI on a terrorist incident which happened in the US. And there has been a request from FBI to unlock this device or to provide some special hardware software update, asked Apple to give a special software update for this device so that they can take the data out of the terrorist device. It was an iPhone 5C model. So one interesting question there is, why can't they, we know that passwords are generally, especially in a mobile, it's a pretty limited one. It has got, let's say, 5 letters or pins, which has got maybe 4 digits. If it is such a small password, why FBA with all its computing power, which can back it, why FBA didn't try to brute force that particular phone and try to take out the data, try to unlock it just by brute force? Any idea? Anybody has got an idea? Yeah, so what will happen in the limited number of, after the limited number of attempts? Yeah, okay, it was right after the limited number of every successive attempt. After 4 attempts, it will start becoming slower, and after the 10th attempt, it will erase the data. Now, as this, suppose if that is a brute forcing part of the passwords. Let us say if the user is using a very simple PIN, let's say a 4-digit PIN. So we know that the strength of any cipher suit or any it was an AES encryption. We know that the strength of the key is directly proportional to the salt, which is given by the password in this case, because it was a password-based key derivation function. So wasn't it possible for FBI, considering that the key strength is very weak, to break this encryption? Why they didn't try to do that? For example, they can take the entire data out from the mobile, and they can take the data out from the flash, put it into a cloud instance, run use a massive computing power, and break, because it's a very, very small key. They can break that scheme. Why it wasn't done? Okay, so the interesting fact is Apple engineers were well aware of it. So what they did, not just Apple, for that matter, every OEM does today, and even in Android also, what we are doing today is, there is a hardware key, which is fused to the hardware at the manufacturing time. And that's a 128-bit key. When user is providing this 4-digit password or PIN, that key, that password, along with the unique hardware key, used for generating the encryption scheme or generating the AES key. Once this data is taken out from this mobile, then this unique hardware key cannot be accessed, so this cannot be broken. And if you are trying to brute force within the device, after a certain number of attempts, the data will be deleted. So that's the reason FBI asked Apple to give a software update so that the limit on the number of attempts can be removed from the software, so that they can keep brute forcing it. So that was the case. So it is the same scheme followed in Android as well. There is a hardware key which is fused to the hardware at the manufacturing time, and which is used along with the user password for encrypting the disk. SE Linux, we know that SE Linux is in the cloud domain, in the Linux domain. It is in existence for a long time. It provides mandatory access control policies and granular. It's the same thing which is used in Android as well. It added a MAC protection along with the DAC to the processes. Verified boot. So we know that rooting a device is very popular. Rooting is done for multiple purposes, but sometimes rooting can be really dangerous. Especially the rooting is done by a user and he is using some sensitive applications in the device. To prevent booting, or at least to prevent rooting, or at least make sure that user is informed when rooting happens, verified boot, what it does is it actually, okay, we know that booting happens in multiple stages. So after one stage, the bootloader level 1, level 2, level 3, and maybe at the level 3, the kernel and the rest of the platform will be coming up. So every stage will verify the next stage. That's what happens in the verified boot. So there is every stage software is signed with a key, and that key has been available to the previous stage, and it checks whether this is signed with the right, it's the right image which I am trying to load. System updates, a normally very often overlooked area, but it is extremely sensitive. How often we check what is the security level, or what is the software security level in our device. Okay, in multiple OEMs, it may be different, but there is a tab typically in our about device or somewhere in that area, which tells what is the current security status level of this device. So whether it has got the October update or December update or January update. These security updates are extremely important because there are known vulnerabilities which has been published by Google, which has been found by other researchers, and these vulnerabilities are fixed in this security updates. If our devices doesn't have that security updates, it means that we are vulnerable to the threats which are exploiting those vulnerabilities which are already published. So we are sitting duck in that case. And one more thing which we normally don't notice is the original equipment manufacturers for a device. They have a lot of they have got applications with a very high level, very dangerous level of permissions are they have installed in every device. So it is important, along with Google, it is important that the OEMs are also publishing their monthly security updates and patching the devices, because an attacker can make use of the vulnerabilities in the OEM application, which is working at the same privilege level as the root or system or any, let's say, anything which is critical. So KeyMaster, it's a key store, hardware-backed key store implementation. There is a software implementation as well. So again, here the critical thing what we need to note is everything can be implemented in the software, or it can be implemented it can be backed by the hardware. So KeyMaster provides what we call as an hardware abstraction layer for OEMs to implement the symmetric key generation, or as well as the operations with the asymmetric keys, with your signing and using a hardware-backed key store. Okay, so we were talking about this hardware-backed multiple times. So what is hardware-backed? So typically in system engineering, we go with the premise that we don't believe, or from a security perspective, we can't believe that the normal world is safe. So when we say normal world, in case of Android, it's an Android OS. It's a large code base, and the Linux kernel itself is pretty large. There can be multiple vulnerabilities in that, and it is impossible for us to assess the security or attest the security of the OS and kernel within Android itself. So the design for most of in a secure design, we need to have a normal world, we need to have a secure world. And this has to be, the hardware resources used by the normal world should not be used by the secure world. The channel of communication between normal world and secure world has to be via some defined interfaces, which is where we can take the right measures for ensuring that no malicious activity is or going from normal world to secure world. So if an attacker got access to the normal world, let's say in a rich operating system, the sensitive data, since it is residing in the secure world, it is still safe. It can be the keys, it can be the tokens, or it can be the biometric material. So it is important that it is residing in the secure world. So it can be provided in multiple ways. In case of ARM, they provide it called ARM Trust Zone. In case of, there are other options. There can be embedded MMC cards, or for that matter, even the SIM card is also we can be considered as a secure world, but there are limitations of using all these. ARM Trust Zone is the most widely used mechanism for ensuring security in mobile devices, and maybe going forward even in other IoT devices, maybe in TVs and other equipments as well. So this is an interesting point about rollback prevention. So let's say we earlier saw about how secure boot is ensuring that the next stage in the boot is secure. So one typical trick which is used by an attacker or by anybody with a malicious intent is load the software with a previous version with a non-vulnerability. So it can be, suppose if an attacker got root access to the device, one thing what he can do is he can actually replace a specific, let's say the system server or a system application or even a kernel module with a previous version with a non-vulnerability, and from there he can do a privilege escalation to the rest of the system. So to ensure that it is important, there has to be some hardware-backed mechanism for preventing rollback. If I am at Android security update, let's say I got the January update, there should not be a case that a firmware with October only security updates till October is allowed to be loaded into my device. If it is being done, it is done with a malicious intent. And that should be blocked. So to block that, we need to have some, what we say as some one-time programmable chip or one-time programmable ROM, something is needed. So we heard about this kernel, and all of us know that kernel has got a lot of vulnerabilities, a lot of issues. If we just have a cursory look into the CV exposures in the mid-trace side, or the NIST, or let's say even in the Android security update, we can see that every week there are hundreds of vulnerabilities in kernel and in the sensitive pieces of the software is coming out. So